name is Pete Saronis. I am super excited to facilitate a discussion today, a conversation with our guests. I am the CEO of Dots and Bridges. I'm the former Chief Technology Officer at the U.S. Department of Energy, and it is a true honor to work with Anterix, a great company, bringing a discussion today to a community of folks in our country and around the world that are experiencing living our critical infrastructure at risk. We are dealing with everything from the Colonial Pipeline situation to an executive order on cybersecurity that was released yesterday by the White House. And today we're going to talk with some incredible thought leaders that know how to enable a grid that needs to be more resilient, a grid that needs better communication and connectivity. And we'll use terms like private LTE and broadband to really illustrate the opportunity in addition to the challenges that our power grid today faces. So without further ado, I'm going to introduce our guests here. Rick Nicholson from Hitachi ABB Power Grids Global Digital Business Development Manager, a writer, a blogger, a storyteller. Super excited for you folks to meet Rick. He talks about connectivity and the complexity of a distributed energy resources environment that is so important when you're dealing with supply and demand. Rick, great to have you with us today.
Thanks, Pete. Appreciate it.
You bet. We've got Steve Hassel, the CEO of Atomation, a great company. Steve brings, what I love is that he's rolled up his sleeves, served as a chief information officer. He's a practitioner. He loves to solve problems, but I can relate to that, being a former deputy CIO and having an opportunity to be a chief technology officer. To talk about the bits, to talk about the ping and the power and the pipe. He too will address how his company and his thought leadership is focused on the complexity of our grid and how this edge computing and edge devices and dependence on sensor networks and those analytics that we cull from this new normal, new network we're dependent upon all comes together. So thank you, Steve.
Thanks, Pete. Great to be here.
All right, buddy. Rounding us out, Alex Hodeling. I got that right, correct, Alex?
You sure did, and it's okay
Awesome.
if you didn't.
That's all right, man. You know, I was telling you earlier, Saronis is a rough one as well. For those watching saying, why doesn't he say the T? Well, because it's silent. Alex is another amazing thought leader who understands messaging. Alex at LineVision will talk a lot about the significance and importance of real-time communication when products and devices that must be integrated but also implemented in a manner that allow us to take advantage of those insights, actionable and applied insights, and address risk, cyber risk, physical risk. And I think you're going to be very enlightened to hear from him as well. So Alex, thank you.
Thank you.
All right. All right, folks, just to frame it before we kick it off, we have an hour together, so we're going to get into a lot of things. We hope our audience will tweet, will share, will take down what they think was compelling, because we're here to tell stories and to hopefully teach and educate and inform. I do need to address, because there was some exciting news on May 10th with Anterix, who is, by the way, the largest licensed spectrum holder in the 900 megahertz band. We'll talk about that and why that band is so significant to our utilities. Rob Schwartz, Morgan O'Brien, Gina Ash, Deanne Campbell, Chris Gutman McCabe, Ryan Gerbrand, Alice Moy Gonzalez, and the slew of people at Anterix are just incredibly passionate. I hope you get a chance to meet them, but once you meet them, you'll understand why this matter is so important to them and their company. They've launched the Anterix Active Ecosystem Program. You can read about it. There was an incredible press release. You can learn about the Anterix Active Badge, which is intended to help product companies bring to market their solutions so that integration works. And to be fully clear and transparent, just because I get this question off and on, is how does this new program correlate to the Utility Broadband Alliance, which is another industry collaboration environment? They're separate, they're complementary, but they're distinct. UBBA is focused on that acceleration of the education of how the utility sector is coming together to share use cases. So between the Utility Broadband Alliance and the Anterix Active Ecosystem Program, what an opportunity for those of you who want to be involved with members such as these individuals and their companies represent to get involved. So there we go. We've still got 53 solid minutes. I hope I'm not sucking too much air out of this one. So with that, With that, Rick, Steve,
Yes.
Alex, in that order, we're going to go back to you. And Rick, please use this opportunity now to fill in some blanks. I did my best to high level. I don't read the bio, obviously, but you work for an incredible company. You care about this topic. Share with us a little bit about your journey and why you love working at Hitachi.
Right. Well, maybe start with a little bit of context. So Hitachi ABB Power Grids used to be the Power Grids division of ABB. So, the history goes back, whatever, 125 years of dealing with power and automation. And then a year or so ago, we were spun off as a separate company, 80% owned by Hitachi, 20% owned by ABB. So our mission remains the same. It's essentially the same set of people, but now we're part of a much larger group of Hitachi companies. And when it comes to all things digital, that's really given us the opportunity to accelerate what we do. And I'm part of the digital team at Hitachi ABB Power Grid. So our connection, our direct connection to Anterix is through our wireless solutions group. But I'm looking much more broadly at kind of how do we work with our customers, our power grid customers, which are primarily utilities, but it extends out into anybody that is supported by the grid. So it could be a renewables, like an offshore wind developer. It could be somebody developing microgrids. It's a pretty broad audience. It's not just utilities. But how do we work with those stakeholders in the grid and support them in their digitalization initiatives? And as I mentioned kind of earlier when we were just having our chat, we're at this inflection point, right, where all the forces are coming together. We're going through this transition of the energy ecosystem. We're introducing, carbon-free supply renewables, both at utility scale and at distributed level. At the same time, we're electrifying huge portions of our society, primarily focused right now on transportation, but it goes beyond that to buildings and everything else. How do we go through that transition in a way that maintains reliability while introducing a fair amount of complexity into the grid? And that's kind of what I'm all about is, how do we work our way through that transition in a way that creates value for everybody? So that's my intro. How's that?
Well, I love it. And we're going to dive into some of that, words like digitalization, partnerships, inflection points, transition. Obviously, things happen all the time, right, Rick? And we have to investigate, respond, and use that as opportunities to transform and modernize. So thank you. Steve, let's cut to you. I mean, again, I mentioned your prior roles and your leadership, and here you are leading a company now. When I think of what Rick just said about the complexity from, we all had data centers that were our warm fuzzies when we had these brick and mortars, to now we're in cloud and we're expanding. Can you build off of that, and as well talk a bit about the awesomeness of Atomation?
Yeah, I mean, if you look at computing in general, it's always gone through these cycles of where you have a lot of very efficient processing at the center, and then it explodes out to the edge to where people really want to use the information. You did mainframes, and then you did green screens, you did client server, then you did mobile, you did cloud. Now what you're really doing is edge computing. And that's where Atomation is right now. The idea that if you're sucking all this information into one point and then trying to come up with the magic algorithm that's going to solve it, it's probably going to be too complex and too expensive really to be able to deploy. So what Atomation does is turn the problem on its head. The idea is if you break a lot of things down into very small packages and then solve them locally, you can solve the problems faster and more efficiently than trying to do it at the center. So think about something as simple, since we're talking about electrification utilities, think about your utility pole infrastructure. Here, I'm in St. Louis, so we've got Ameren as our local utility. They've got over 3 million different devices that are out there. How do you know when a storm goes through whether a pole is up, down, damaged, not? Right now, what you have to do is send people in trucks. If instead you had shameless plug, simple devices that are attached to the poles themselves that are asking a simple question: am I up? Am I leaning? Am I down? Are the lines above energized or not? Making their own decisions on whether they're good or bad, and then communicating back through a network like Anterix's back to go and let the operators know what's going on. What you would see in the case of a storm is within minutes, you would be able to see tactically what's going on with your infrastructure and be able to get resources on the actual broken pieces a lot faster. It's a kind of eliminating the fog of war type of a scenario. So that idea of breaking big complex problems down into simple things that you can determine, good, bad, on, off, those types of questions, then distributing it out to the edge, that's what we're doing. So it's, it is a little bit of a turnaround for somebody who's spent their entire career saying, if we could just centralize more stuff, we'll be able to win. But I think after, again, more years than I'd like to think of trying to go at it that way, it was time to do a fresh look with a startup like Atomation. And we really are getting some traction.
Well, thank you. And I think you very eloquently talked a bit about this grid that's in transformation, and coming to Alex and this you can always go down the rabbit hole, Alex, right, of risk. And I think it's very important that there is security and there is cyber risk, physical risk, network risk, and devices, to Steve's point and Rick's points. And obviously, I'm sure you'll hit on it. The devices are the tangible things we see, and we don't plug and play when it comes to this type of innovation and opportunity to integrate such a complex network. So Alex, taking that and some of your opening remarks, talk to us a little bit about LineVision and why it's a special place to work and why this topic matters to you.
Yeah, thanks, Pete. I'm glad you asked that question of me as well about why I like working at LineVision, because when you asked Rick, I had to think about it for a second, because there are a lot of reasons that are very focused on our world. But looking at this at a more macro level, I read the Times every morning. And I think one of the most exciting things that I think we probably all share is that the industry that we're in is relevant to, at least 50% of every single news article that's out there every day. So whether it's cybersecurity right now, or infrastructure, or for LineVision, our work to address climate risk and the ability to incorporate more renewable energy, those are all things that are incredibly topical, incredibly important to the world. And so I think we all share this, that we're participating in an industry that's evolving, but is also very front and center in everyone's collective consciousness. And it's a really exciting place to be, certainly. And none of it works without communication. So I was listening to Steve's comments about connectivity and devices. LineVision is similar. So we have built technology that uses LiDAR and attaches to the poles as well, specifically transmission poles. And what we're doing is looking at the conductors themselves, so the overhead wires, and gleaning very important insights about the position of those wires and what that means for their overall health, the ability to incorporate more renewable energy, and the ability to mitigate some of the challenges connected to climate risk, wildfires as an example. And I think one of the reasons this is such an important conversation that we're all part of is that whatever our respective technologies are, if we don't have the means to communicate this in real time, then that information is useless. And the topics that we're addressing are so important, it's really necessary to have a secure, safe system to be able to communicate this information.
Thank you. Thank you so much, Alex. And again, I think now we're going to move into the conversation where maybe we can spend the first few or the first segment talking about sort of that technical, the connectivity, words like spectrum, which we know is critical to critical infrastructure, how we communicate. Yeah, bands of the radio spectrum are significant for obvious reasons. There's been some recent panels discussing FCC and the role that Anterix has played in pioneering and leading a lot of the movement towards why the band of 900 can benefit a utility that might be working in a lower band. But propagation comes to mind, and the opportunity to take advantage of the devices and solutions that your companies have built. So Rick, maybe if you can kind of kick it off, and you mentioned connectivity, maybe speak to the significance of private LTE or broadband communications, or wherever you want to go with it, but to help educate the audience.
Yeah, sure. Happy to. And I think kind of Steve and Alex have already kind of teed this up a little bit. But when I look at it, and I guess when kind of my company looks at it, we think of digitalization as being a journey, right? That the organizations, companies go through a journey, and that journey starts with data, right? You can't really do anything without data, and data that's going to drive change, right? It's going to drive decisions. It's not like we've never had data, because we have had data always, but we're at the point now where we can start making assumptions around everything being connected, right? Everything and everyone being connected. So whether it's a sensor on a pole like Steve mentioned, or millions of poles, or whether it's LiDAR sensors on transmission lines that help you do dynamic line rating like Alex mentioned, or whether it's sensors in a substation that are providing you additional information, real-time or near real-time information on the health of your equipment in that substation, like power transformers or circuit breakers or whatever. We're kind of at the point where we can't get by without that level of universal connectivity. I'll add secure connectivity to that, and kind of go through this transition to a future energy system or a future energy ecosystem without it. So I mean, I'm not the kind of, let's say, the wireless technology expert on the panel, but I always go back to you have to get to that point where you've got that universal connectivity, secure connectivity, to support everything that you want to do to make your way through this transition.
Yeah, well, Rick, and I'm going to come over to Steve here. I heard you all but emphasize resilience and interoperability, and devices and standards that are born out of the wonderful institution, the National Institute of Standard and Technology, and the work with North American Electric Reliability Corporation and the Federal Energy Regulatory Commission. This ecosystem, as we call it, of stakeholders are so important to being in the discussion. And when devices are created, Steve, can you speak to the significance of all that hard work that leads up to you having something that folks want to buy and should buy, especially for the power grid, but trust that it's going to be a device that accelerates that opportunity to move to a resilient, sustainable, flexible grid?
Yeah, it's key, and when you're looking at building resiliency, I mean, there's multiple different ways you can do it. I mean, traditionally, you've looked at it through redundancy. I'm going to go and create 4 different versions of something operating in parallel in case one fails, the other ones can pick up. But the other way to do it, and this is the beauty of using broadband and wireless as the ability. What you can do is you can also provide independence. If everything has its own independent route to talk back, the entire system is naturally resilient. And you can't practically do that for something like the grid, which is already in place. You're talking about retrofitting existing equipment with technology. And it wouldn't be practical to say, oh, well, we're going to do that. We're going to run an individual line out to every asset out in the field. The only way to do that is through something like LTE, the 900 megahertz network, doing it wirelessly. And again, to the degree that you can eliminate these individual junction points, which become, your critical failure points, you make a more resilient network. So that's really what we're trying to do, is to try and give every individual and object its own independent voice. And by using providers like Anterix, that makes it a reality.
Thank you. And I think that tees us up nicely to Alex, coming to you, in that you've mentioned analytics. You've talked about information and sensing. LineVision alone just tells me I have an idea of what the company is all about, the hygiene of a network. If you can speak to that component that is, while connectivity and communication is so important, shaping it, whether private LTE is your primary or redundant network. Steve, you mentioned it. The network can be in a silo, but also can be air gapped, but can also be connected. And I think what we're learning, that there's no shortage of great products, but when we introduce a new product to something as complex as the grid, having good intelligence that is both actionable and prescriptive is important. And if you can address some of that from a risk perspective as well, Alex, that would be really, really helpful.
Sure. I mean, right. You mentioned active and prescriptive, and I think those are two important themes. But I would add in the sense of urgency you would have around certain data sets. And what we're doing at LineVision is all predicated on having real-time information. So whether it's understanding real-time risk of wildfires, or understanding exactly how much more capacity you can put on the grid at a given moment to incorporate more renewables, there's a time factor that's involved. And for us, one of the things that working with Anterix has been really exciting is the fact that we can do data packet prioritization. So obviously this would be up to the utilities, but giving them the ability to designate different data sets that they want to have in real time versus others that may not have that same criticality is key, because we would argue that the information we're providing is urgent and critical. And if you don't have it in that time frame, you just can't achieve what our technology needs to do. So, I look at connectivity, I look at what Anterix is doing. It's just foundational to what we're doing. We just can't do it without partners that are able to give utilities that flexibility.
Great word, flexibility. And again, folks, for the audience, there's a number of resources that I feel, I mentioned one earlier at the outset, that I think speaks to the significance of the world we're living in. Again, the White House just released yesterday the new executive order on cybersecurity. It's a great read if you haven't read it. Tune into the news. You can probably hear right now, real time, the president, and as well as some of the cabinet level agencies addressing the Colonial Pipeline issue, which spoke to impact on humanity. And I think that's, again, something our guests today are saying their products can help mitigate risk to humanity. And let's not forget that the grid itself is an engineering marvel that's well over 100 years old and needs an upgrade, but it's not a rip and replace, it's a complement too. So moving from the connectivity and of course broadband and wireless and wired communications, everything's in play here. So Rick, bringing it back to you, you've worked with clients globally. We talk a lot about the United States and its power grid. Have there been some exemplars or stories that excite you about some of the capability of not just products like your own and Steve's and Alex's, but maybe speak to this global effort to build resilience into country grid infrastructure?
Yeah, I think there is actually some great examples, and they're kind of like, let's say, all over the map as far as kind of how far along are they. Being working for a global company, as you mentioned, we see companies that are attempting to go from kind of like a traditional legacy grid structure to something new. And I'll use the example of China. Highly innovative on the high voltage transmission side of things. Building high voltage DC lines to connect huge resources, wind farms in remote locations, basically supporting kind of the economic growth that we've seen in China, through investments in their transmission grid. And I guess getting back to how do you do that in a way that, for instance, without the ability to sense that transmission grid and all of the equipment associated with it, and being able to then predict what is what the potential failure points are, getting to the risk issue, what's the risk associated with all the equipment that makes up that grid, and then getting into prescriptive, what do we do to keep this this grid performing, especially when you've got, let's say, less and less inertia associated with that transmission grid, because you've got less and less kind of spinning mass in the form of traditional generation, and now you have to introduce other kind of power electronics to make up for the lack of inertia. So you've got a great example there. You've got other countries that are way ahead on the distributed energy side of things. So I was thinking when Steve was mentioning the challenge of how do you connect up all the stuff that's already out there, millions and millions of endpoints, but you've got the additional challenge of connecting all the new stuff. How do you connect up every solar inverter at every house or every building? How do you connect up every battery energy storage system? How do you connect up every EV charging station? And you look at some of the European countries, you look at some of the states in Australia, they've got such huge growth in distributed energy resources, and so you almost got the double problem of connecting up the legacy stuff and connecting up all the new stuff. How do you keep up with that? Well, to me, you once again, you can't get there from here without a broadband wireless network.
Okay, so let's take that, Steve, and Atomation preaches the industrial Internet of Things, connectivity to legacy systems. It's not RIP, as I said earlier, and replace, but it's two terms that are acronyms, or what you want to call, you can read about, are OT, IT integration. A lot of the utility world speaks to this industrial control system language, vernacular around operational technology and SCADA and distribution control, distributed control systems. Legacy doesn't mean we need to get rid of it, right? It's, hey, it works, it's functional, it serves a purpose. But the internet and all these devices that can bridge that. Can you speak to some of that capability that Atomation brings, whether it's through in a use case or example, but you are a bridge. You're bringing legacy into light and saying we can learn and work with as we introduce new tech.
Yeah, that's exactly correct. And there isn't, nobody's invented the wand yet that's going to go and just you wave it and it makes everything better. So what you've got is always have a combination legacy infrastructure, new infrastructure. And for me, throughout my career, I've always said that if you're going to go and create closed loop systems, you first need to see what's going on. You then need to decide what to do, and then you need to be able to take action. If you look at the traditional OT type systems, they've got components of all three. Very heavy on the act side, with analytics and everything coming in now more on the decide side. The place where they need some shoring up in a lot of cases is the C side, because the systems have been so complex and so costly, it hasn't been practical to wire up every device. So what you get are gaps in your system where you can't see what's going on, which then impacts your ability to make decisions, and then ultimately your ability to act. What Atomation is doing is we're not saying you go in and rip out anything that you have. What we're about is filling in those types of gaps, augmenting what you're already seeing so that you can make the better decisions. And that's, we do it in the utility infrastructure. I mean, something as simple as, as transformers, often a blind spot, when you're talking about whether they're pad mounted or pole mounted out there. Things that fail on a regular basis that do give indications before they're going to fail, but due to a lot of different reasons have not been fully instrumented. What we do is provide simple, cost-effective ways to get information about those, to give you the indication that something might fail so that you can use your other systems to go and then take the appropriate actions. So it's more of building out a team than it is going and saying, we are the one technology that solves every problem.
No, wonderful. And thank you for, again, just expressing how in a world that's dominated by a cool device, a cool widget. I always love saying the word, so does Morgan O'Brien, I think, synchrophasers, phaser measurement units, and what they do. And it's like, well, it's one of many. Alex, I think of LineVision and this messaging around non-contact sensors and your cloud-based analytics and the end-to-end security. It just sounds very IT, next gen, what everybody's doing. And the ability to apply it to a century-old infrastructure. Can you speak to, again, what you're excited about as we embrace the internet or the industrial Internet of Things, and how LineVision respects legacy?
It is interesting. I think that the grid is an advanced organism, but it fundamentally hasn't changed in many years. The oldest conductor that LineVision monitors was strung in 1926. And so you think about that, and that's of course the exception, but the reality of it is this is equipment that's been out there for a very long time. It still works, but there's a lack of understanding around the current state of many of the assets that are out there. So both Rick and Steve had mentioned the ability to get objective information, and that's how we see it. This is objective information that we're providing to our utility partners to allow them to format a business case and say, okay, now I understand the health of my conductors. Now I can do these things to improve that. And that's really predicated on understanding that the grid is changing, and perhaps that's being driven by changes in generation. Rick, you were mentioning distributed generation, and I think that's a huge forcing function. It's creating an environment where generation is much more dynamic than it's ever been. And so you need a transmission system that is equally dynamic. You don't have generation right next door to the load center anymore. So an example would be in New York State, where you have vast capabilities for more renewable energy, both wind in Western New York and in the North Country, and then offshore wind off the coast of Long Island. How do you get that to the load center in New York? You see this funnel effect where it needs to get there. And new assets are a part of that. So I know we've said several times that it's not a rip and replace, of course not, but there is a component that more transmission is going to be necessary. But even if you're building new transmission, there are challenges that come along with that. And it almost increases the need to have a more digital environment where you can plan it and mitigate some of the downside risks of ripping and replacing what needs to be ripped and replaced. While having a higher degree of digital understanding to make that as minimal as possible in terms of the pain associated with that. So really, we're adding technology to the grid that's giving us a higher degree of understanding, and that's great. But it doesn't replace the need for us to physically upgrade the grid. But even with that, we need a higher level of awareness that comes from these types of devices. And obviously, it goes without saying that if you're going to put a lot of devices out there, of course, you need that secure system to be able to connect all those things so people can make the best informed decisions.
Yeah,
Pete, can I jump back in for a minute?
I was going right to you, brother. I have a question for you, but go ahead.
As we were talking, it just kind of occurred to me that, using that analogy of, when we had kind of limited data, limited number of points connected, you could kind of go with that SCADA system architecture and mentality where, you're taking data in and a person is evaluating that data and then making a decision to change something, to change a control setting, to do something. But as we're getting to this point where everything's connected, we've got lots of real-time data. We also have to think about the level of autonomy that we're going to need, right? So we're going to have to move towards autonomous systems that make decisions on their own, as opposed to always relying on, let's say, somebody in a control center looking at data and making that decision. And in the kind of popular media, autonomy tends to be translated to autonomous vehicles. But we're seeing all sorts of applications of autonomous systems in utilities starting already. We're seeing robots that roam around offshore substations to do inspections because we don't want to send people there, and they have to have a lot of data, a lot of real-time data, to be able to perform that function. So I think we need to kind of think about the need for connections, for connectivity, and data to support higher and higher levels of autonomy.
Well, and it's a different level of data than what we used to talk about, because for a long time, what we've had to do, because computing was rare, so you had to have it in one place and then feed the information to it. So you got this, data meaning everything about everything all the time. And what we did to the operators who were trying to make sense of it all is we overwhelmed them with information. They ended up going and becoming numb to the over alarming, because they were getting told all the time that things were bad when they really weren't. And so you started building up almost a resilience against all the flashing lights and everything else. Automation can go and help curate that information, to go in and do the first couple levels of analysis. So the only thing that ends up getting to the decision center is the actionable information that you need to make the decision. So it isn't just the robots are going to take over and we're all going to be eliminated. There's still going to be a need for people to make decisions. It just allows people to make better decisions because that first couple layers of information has already been worked on for them before it gets to them.
Alex, you have some comments? I saw you nodding your head.
Yeah, I just want to go back to something that you had said earlier, Steve, and you made me think about it, Rick, as well, where you're putting more sensors. You almost create a positive feedback loop where you have more sensors. It requires more sensors. And I think a good example of that is with what we're working on. So if you think about the grid like a highway, there are going to be areas of congestion. There are going to be pinch points. And our technology is designed to alleviate those pinch points and open up more capacity so the cars can move. But sometimes what ends up happening is once that traffic is dislodged, it often gets backed up on parallel paths or some of the smaller roads. And so that creates a need to then go have the technology on those smaller quote roads as well. And so I think that, right, Steve, the early instances of alerts and alarms and your dashboard lighting up red, I think was a headache for some, but I think that at least we're in a position where that's really not a challenge as much anymore, because we are taking some of those steps to make it smarter. But recognizing that the more sensors you have, it creates this spider web effect. And I think that's a good thing. I think it mirrors the grid. That's really what the grid is. And I think the sensing capabilities need to be more dynamic to be able to meet that.
Yeah, I'm gonna pivot here, folks, because that was awesome riffing, by the way, and I love the organic nature. And please, like I said, I can ask 50 questions, but we really are now, I think, getting into the how do I even build a roadmap to do this, right? There are devices. I want data-driven decision making. I absolutely want to take advantage of the power of resilient distributed energy resources. The last 3 days we kicked off our week with Motorola, Ericsson, and Nokia talking about the the significance of those, century-old companies who know how to build the infrastructure. And again, we've been using terms, audience, this is for you. Generation, transmission, and distribution is about as simple as it can get in terms of, what power source is going to allow us to turn our lights on. The next discussion we had dealt with utility grade evolution and the FCC certified devices. We addressed standards. Looking at my notes, we had John Yaldwin and we had folks, Jatinder and AJ yesterday, talking about how do you architect and ultimately use the right devices, not just something someone built in a truck, but is actually certified for use. And today, where I like thinking we're talking about in that third leg of the stool, the excitement around these next generation components in a grid that's extended itself to an edge, to Steve's point. So with that in mind, I'm going to come back to Rick and Steve and Alex, and I'm going to put the question out there. When Company X, and I feel this is what Anterix is trying to build with their ecosystem program, is we want to help incubate, we want to help accelerate the development of these products so that they can be for good use and be implemented properly. Rick, what are you feeling are the types of things companies should be doing when they're contemplating, it could be a utility, to embrace this next generation infrastructure? I mean, strategically, there's a lot of people that have to have input, right? The C-level, the operational folks. How do you go about road mapping for something like this?
Well, this might not be exactly the answer you're looking for, Pete, but let me give it a shot. Independent of any discussion around technology, when I think of roadmaps, right, I think of why are you building the roadmap in the first place and what's the outcome you're looking for. And let me just kind of give you a little bit of a view. So we just recently did a global survey of our utility customers and asked them questions around, the value of digitalization. Why are you doing it? And got some pretty interesting responses. The most frequent response was, we're doing it to support reliability and efficiency. Not a big surprise for a utility company, right? I mean, that's some of the core values. Second most frequent response was, we're doing it to reduce our costs, typically our OpEx costs, but in some cases CapEx as well. And then there was, a number of other reasons after that. But, I go back and I look at that and I say, okay, well, if those are kind of the value drivers, now you can start to put together a roadmap that aligns with the value, that business value that you want to create. So if what you're trying to do is drive increased reliability, you're going to put together a roadmap that lines up with that outcome. If what you're trying to do is reduce OpEx costs through, better maintenance procedures, asset management processes, you're going to put together a roadmap that lines up with that, right? So at a high level, I think you have to always start with, what's the business outcome or outcomes that you're aiming for, and then a roadmap that takes you from where you are today to that goal in incremental phases where you're seeing actual results at each phase along the way.
Yeah, I'm going to borrow one of my mentors when I thought I was like the coolest project plan developer in an early day in my career. He said, Pete, show me, in this case it was a man, but he goes, show me in this case, he goes, show me a man without a plan, I'll show you a man who plans to fail. I love it. And to this day, I was like, yeah, I got a plan, but I don't really know what I'm trying to achieve. So net, I love your road mapping. And then what are you trying to achieve? And there's lots of outcomes there.
Having said that, I do see commonality in that, there's themes or phases that our utility customers pretty much always go through, right? And kind of the first phase gets back to that, we want to securely connect as much stuff as we need to support whatever that goal is.
Sure.
right? So that's almost always somewhere in the beginning of the roadmap is, securely connect all the stuff that we need and give us the data that we need to achieve those goals, right? And then they'll move on to, okay, now that I've connected the things that I need to connect and I've got the data that I need, now I need to drive something. Maybe it's I need to, drive, like I said, reliability. Maybe, I'm driving some other
Sure.
goal, but that's not an
Yeah.
uncommon first phase.
Yeah, it's think with the end in mind, and well stated. I want to jump to Steve because again, I know you have product that is a resilient enabler, a resilience enabler. Can you speak to the significance of when you're pitching somebody or working in concert with, or maybe through the Anterix badge program? Again, I have to give a shout out to that, the Anterix Active Badge, which should feel like the Intel Inside, I would hope one day. What is it that you help advise, or what you feel customers need to know about what Atomation and what they need to think about in order to develop a roadmap or a plan for success?
Well, one of the things that that I've learned over my career has been you do need to have that end goal in mind and then work backwards. But what you don't know is what you don't know. And usually you can spend, hours and hours and hours putting together this super micro detailed plan. But because you don't know what you don't know, it's going to be 100% wrong. So the thing that I try and coach people at Atomation and then anywhere else is create a plan where you're going to be directionally correct and then start and gather information and then adjust. In most cases, the goal isn't going to change, but the absolute path might be. And one of the things that we do, at Atomation, because the devices are self-contained, you don't need to have an elaborate architecture or anything else like that's thought out. What we tell people to do is to start, to put the atoms out there, to start gathering information, because you're going to see things and discover things that are going to make you look at the problem a little bit differently. Then you can adjust, refine the plan, and then go out into full production type of a mode. I think too often, and this is particularly true when you're talking about very large, complex organizations like utilities, they'll spend so much time planning and trying to come up with the ultimate answer that they never actually take the first step and start making it and start taking action. It almost becomes analysis by paralysis or paralysis by analysis. So the key is to start, start within a contained environment, get the results from that pilot, feed it back in, and then let the entire project build momentum on itself.
Alex, let me jump to you because I think of LineVision, and you have such a rich resource, not just on your publicly available website, but this ability to convey that, hey, to build it, it takes effort, but specifically to utilities and concerning yourselves with the health of your legacy. Can you just kind of tie this up with this discussion on strategically what it takes to think about that grid of the future and how LineVision can help accelerate that roadmap development?
Sure. I think from the discussion I've been hearing, communications and our technologies are on the same directional path that you mentioned, Steve. What is that end state? And as I've said from my opening comments, if we don't have a communications network that allows us to get our data sets to the operators within the utilities, then it doesn't do anything. And so the pathway, for example, that Anterix is following, the pathway communications companies are going down, really needs to be parallel with technology development. And for us, what's important is, from a directional standpoint, making sure that we're able to have geographic reach. Excel, as an example, has 20,000 miles of transmission, and those aren't all outside of Minneapolis or Denver. They're in very rural areas. So the ability to give them a level of awareness for that very rural area or the more urban area is equally important. It's the same lines, it's the same problems that exist. Also, the need to have flexibility. So each individual area is going to have its own challenges with connectivity. But if you don't have flexibility, it just makes it more difficult. So one of the things that we really like about Anterix is the dual SIM availability. So we don't have to go with any one tool. There's a higher degree of flexibility. And then for LineVision standpoint, what we try to tell our customers is that we're very easy to implement, we're easy to work with, we're easy to use, and that needs to be mirrored with a communications plan. And I think about Macs as an example. You take a Mac out of the box and you just turn it on and it works. And I think that that's the level that we all need to get to, where you don't have the level of integration challenges that we currently have. We spend an enormous amount of time with the IT departments within utilities. And a lot of that's, of course, based on security, and that needs to happen, of course. But I think there are a lot of things that need to be improved for this out of the box type thinking, where you can just take the unit out, put it on the tower, it works, without having to go through all of the internal IT challenges. I think that's an evolution. I think that there's progress being made, but ultimately that's the path that I'm sure all communications companies are taking, and certainly the path we're taking. But that's what's going to be necessary to ultimately connect all of these devices. It needs to be easy to use.
Yeah, technology due diligence is so significant in the what do we want to build and where are we going with that vision. So, all right, we're going to move into the parting shots. We've got about 5 minutes here or so. So I'm going to ask Rick, Steve, and Alex to, as we did in the prep calls, just leave the audience with something that you feel you may have picked up in this conversation. Obviously, what you're passionate about, but its relevance to the world that we're in now, and that's a world that in our description talks about leveraging telecommunications and broadband and computer intelligence. Word computer is still funny for me when I say it, to collect, create, analyze, and act upon data so that we can have a cyber, physical, secure network of the future. So with that, I'm going to kick it over to Rick for some parting shot.
So, I actually am going to key off of something that Steve just said in the previous discussion there, which is, you don't want to get stuck in that, build a micro detailed plan and stick to that. There are always, I think, going to be opportunities, kind of serendipitous opportunities that come up when you have that level of access to data and connectivity that you didn't plan for. And those are the types of things that, that kind of stack value on top of what maybe your original goal was. So if your original goal was, we want to take some cost out of this process, great. But as you're going through that journey, right, that digitalization journey, look for opportunities to do things differently that you might not have thought of. What new program can you offer to a customer now that you have this capability in place? What can you do with a business partner that you couldn't have done previously? Think of all the different stakeholders. I'll give you, it's not necessarily a real example, but it's something that I think is illustrative. If you've got the right level of connectivity and the right data, and what you've connected is an owner operator of a wind farm and somebody that runs a fleet of vehicles like buses. How can you connect those two entities in a way that the entity that's charging the buses is taking advantage of excess wind capacity at a time of day when they would have had to dump that, and not get value for it. So look for those opportunities that are going to spin off a new business model or something else above and beyond what you might have set off to do initially.
Thank you, Rick. Thank you so much. Steve, parting shot.
And I guess I'll riff a bit on both Alex and Rick. I mean, if you think about it, if you think about the problem in layers, as you're putting the different pieces together, it doesn't necessarily all have to be on the same network. It doesn't necessarily even have to be with the same organization. What you're really talking about doing is federating data and then bringing it together at the appropriate point. At some points, that is everything running on the same network. You want it to be from point A to point B. On a lot of other places, what you want to do is to let the systems operate independently and then bring them together, maybe at the cloud layer or someplace else. If you think about it like that and not say that we need to, and this pains me, run everything through your local IT organization, you might be able to get an overall implementation that is quicker to deploy, that is more resilient to any particular threat, and ends up being actually easier to implement. So rather than just thinking you've got to do it all yourself, all with your own resources, all within your four walls, think in terms of, again, what do you really need to do to solve the problem, and what's the easiest way to get that type of information in order to get the problem solved.
Thank you, Steve. Alex, parting shot.
Yeah, so coming back to something Steve said earlier about the challenges of integrating with utilities and proof of concepts, you know, utilities have been very receptive to proof of concepts in my experience. The challenge is taking that next step, going into a phase 2 plan, because look, if you have cool technology, everyone's going to want to get their hands on it. But how do you actually integrate that with a system? So I think that there are really 2 levels of communication challenges that exist, and they tie in nicely with the challenges with generation and transmission. And that's understanding how do you actually give the users access to this data in a way that helps them achieve their goals, as opposed to just giving them a disparate data set that they have to pore over manually and independently. So tying this together, thinking about having that end in mind, I think a lot of collaboration is necessary, both with utilities, but also within the communications world, to understand, look, we're going to stand on each other's shoulders. These utilities have done this with this technology. How can they help others understand it so they can move faster? Because we all know that technology is rapidly evolving, and the ability for both the communications world, the utility space, and technology providers like us to be able to come together in sessions like these and be able to help each other learn, so we don't have to go through that pain of individual proof of concepts and just repeat over and over again, I think is really important. So perhaps that's a bit aspirational right now, but I think that that's the place where we all need to go.
Absolutely. Rick, Steve, Alex, thank you, thank you, thank you. Your wisdom, your knowledge, your passion for this topic is, as we can speak for hours, incredibly helpful. I believe we did inform, educate, and enlighten. I want to thank you for your time and attention to this matter. This will not be the last time we probably talk about this subject, but shout out to you and your amazing companies, and continue to bring it and move that needle.